Bismillahirrahmanirrahim. Assalamu alaikum. In today's lecture, we will talk about the image and pre-image of linear transformation. This lecture is in continuation of our series of lectures related to linear transformation. So, as far as today's lecture is concerned, you may find the relevant section in the book of David Seeley, which is uploaded on LMS in the section 4.2, and also in the book of B. Coleman, chapter 10. And the B. Coleman book resource I will upload on soon on LMS. So these topic regarding linear transformation, all the topics are mapped onto CLO2 of your course. So let's start this lecture. So suppose V to U is a linear transformation from a vector space V into U. So we say that a vector V in a vector space V has an image U. If we say that the vector V in this space V and its image, that is a vector U, such that T of V is equals to U, is called the image of vector V under T. Now for pre-image, we have to see the reverse relation. That is, if we have a vector u1, let's say, in the space u, and we have to trace it back in the space v, and we have to find a vector v1 so that u1 is the image of v1, then we say that v1 is the pre-image of u1. So this relationship is important, and you see that hence we can say that if U is the image of V, then V is a pre-image of U under the mapping T. Now, image of the space V is called the range of T. So we can interpret this fact as, you can also say that the image of the space V is a subset of U, and we can interpret this fact as, if we have the space V and there are certain elements in the space V and another space U, so that under the transformation T, every element of V has an image in U. So if we gather all these images of the vectors of V and we put them in a set, then this set is called the range of T. So this set may be the smaller set that is a subset of U, or it may be the whole set U itself. So in any case, the range of T is a subset of U. Now come towards an example Suppose T is a transformation from R3 to P2R defined by the formula. Now you have to prove that the image of, and now you have to prove that T is a linear transformation, and to find the image of minus 137, you basically need to apply T on minus 137, and by putting in the formula we get 3 minus 1 into T square plus 3 minus 7 into T plus Y minus Z will be 7, and this becomes 2t square minus 4t plus 7, and this vector is called the image of minus 1 3 7. Now what is the pre-image of 3t square minus 2 minus t plus 3? Now for this we have to solve inverse problem. That is, we need to find the pre-image here we put 3t square minus t plus 3 in the space u, and we drag it back, and we need to find this vector v, so that the image of this vector v will be this vector 3t square minus t plus 3. Now to find v, we assume that v has components x, y, z, and v, when t applied on v, will be given by the formula as described in the statement of the question. T of x, y, z is equals to x plus y t square plus y minus z t plus z. Now this leads us to the system. That is, this vector, this image of v vector v, if we equate this image to the given vector, then this will lead us to the system of equation when we compare the coefficients of t square, t, and t power 0. So we have a system by equating these two vectors. We equate this vector with 3t square minus t plus 3. So by comparing the coefficient, we have the system x plus y is equals to 3, y minus z is equals to minus 1, and z is equals to 3. So the pre-image will exist if this system is consistent. So the solution exists, then we say that pre-image will be also be exist here. So if we solve the system, then we see that the system is consistent system, and the solution of the system is x, y, z is equals to 1, 2, and 3. So the pre-image of 3t square minus t plus 3 is 1, 2, and 3 under this transformation t. Now next example, suppose we need to find that whether some vector, let's say 11t square plus 3t minus 5 is in range of t, then for finding or for proving that some vector is in the range of a transformation, again we need to show that the pre-image of this vector exists. So in fact, the previous problem and this problem would be the same problem in this sense that we need to find the pre-image of this vector 11t square plus 3t minus 5. So again, we suppose that the vector xyz is the pre-image of this vector. So that we apply t on xyz, then we have this vector 11t square plus 3t minus 5. And like the previous slide, we again have a system. If we compare these two vectors, so if we compare the coefficient of t, powers of t, then again we have the system x plus y is equals to 11, y minus z is equals to 3, and z is equals to plus 5. So we verified that, and you must verify yourself that the system is inconsistent system and the solution does not exist. So we can say that the given vector 11t square plus 3t minus 5 does not belong to the range of t. It does belong to the space V2R, but it does not belong to the range, which shows that the range is a subset of, strictly a subset of P2R and not equal to the full space P2R, because there is at least one vector that does not belong to the space. Thank you for your attention.